Good day, everybody. Today we're going to look at Huntington Hill and other divisor methods for apportionment. So this is the 2020 apportionment census population, and if I divide the standard divisor into each state's population to get the standard quota, regular rounding actually works. And so Hamilton and Webster would give the same result in 2020. But we're not going to round using 0.5 and above. That's like the arithmetic mean between consecutive numbers. Right, so if you take the floor of each of these numbers, always round down, so 6.61, you go to 6, and so on. 0.97, you go to 0, and so on. Even 51.99, the floor would be 51. So the arithmetic mean is just the average or middle of that number and the next. And so as long as you're above that, you round up. We're going to round using the geometric mean of consecutive numbers instead. So if the floor of the standard quota, in other words the lower quota, is 6, look at the geometric mean of 6 and then the next integer 7, and of course I have that here. So the geometric mean is the product 6 times 7 square rooted. So that ends up being a little bit less than 6.5. But if I start at 1, the geometric mean of 1 and the next integer, 1 and 2, is the product 1 times 2 square rooted. And that's just root 2, so about 1.414. So we're going to use rounding based on that. So if I look at any of these, say go over to here, a little more complicated rule, but if this number, so it's D13, is smaller than the square root of the floor, 28, times the floor plus 1, so 28 times 29 square rooted. If you're smaller than that, then you round down. Otherwise, you round up. You get the floor plus 1. So I do that everywhere. So with that rounding, notice the geometric mean, you can prove it's always below the arithmetic mean. So it's always going to be below 0.5 if you go from consecutive integers. So you're more likely to have too much, and in this case we do have too much. If you round using that, so regular rounding would actually get us to 435, but here we've got a few that we rounded up, and since the geometric mean is farther from the arithmetic mean, the smaller the numbers for consecutive, right? So you can see like 1, I round up if I'm above root 2 or 1.414, and there's a couple of small states here. We've got Rhode Island, that actually rounded up, and Montana also rounded up. So that gave us 437. Anyway, so we're going to change our divisor and lower this. We've got too many, we need to make it smaller. Let's go to 763. That still didn't, oh there it goes. So that's too big. So you have to go smaller, and I know this one's actually pretty sensitive, so I'm going to go 762, 990, which is pretty close. So that's almost at 763. But now it's too much. So this here is a very sensitive one. So it's too much, so I have to divide by a bigger number. So when I had too little, I have to go to a smaller number. If I have too much, I have to go to a bigger number. And so it's very fine. But this number will work. So 762,995. There. Proper rounding. Well, no, geometric rounding gives me 435. And I've got the sensitive ones right here. So Minnesota barely made it, so it did round up. If we look at the geometric mean of 7 and 8, it'd be 7.4833. Well, that's exactly where Minnesota is. Maybe I need more decimals. Why not? Hopefully it shows up here. There. So you can see how much Minnesota barely made it over the geometric mean of 7 and 8. I had to go that many decimal places. That was close. But so it rounded up. New York rounded down. So it's at 26.4953. Again, I mean, that's right on the cusp. So 28. Let's see. 26. So look how close that was. So Minnesota did not get a seat, and this is the actual apportionment, so you can see how close New York was to getting a seat, but well, an extra seat. So of course it got 26, its lower quota. Again, Ohio did not get one, so the geometric mean of 15 and 16. The product of 15 times 16 there, 49.19. That one I can already see. But where's Ohio? Yeah, so 477. So it's under, so it rounded down, but it was pretty close. And but there was one more. Well, so that's who was close. If we want to compare with different years, this is the apportionment. So again, the one used right here in column I, Huntington Hill, it's different than Webster, which in this year was the same as Hamilton, in that it gave Montana a seat and Rhode Island, those two rounded up, and Ohio and New York, and you can see their fractional parts much higher, 0.559. It did not get the seat compared to like 0.426 and so on. So that was for 2020. But they can agree. Let's see, in 2010, there's a little bit more agreement. Hamilton actually agreed with Huntington Hill. I'm not going to do the math, but this would have been the apportionment for these three methods. Webster, though, was different than Hamilton, which we saw, but just by one state. And again, you can see how close they were: 1.485, 1.458. If we go to 2000, Webster and Huntington Hill agreed, and they generally won't agree, but they actually did in 2000. And surprisingly, even though Webster and Huntington Hill agreed, Hamilton disagreed. So Hamilton gave Utah a seat with its 0.46 instead of California with its 0.45. And finally in 1990, a little bit, again, disagreement between Webster and Huntington Hill. And then with Hamilton, disagreed with even more with Huntington Hill, but still some with Webster. So that's a rounding method for Webster. Also note, since it is a divisor method, where you use a modified divisor, it can have quota violations. It won't have the new states paradox or the population paradox or the Alabama paradox that Hamilton has, but it can have a quota violation. And so here, if we look at again an extreme example, it has to be pretty extreme to have a quota violation. So you've got one state with a significant portion of all the population, and things are just contrived for this to happen. But with this divisor, both Huntington Hill and Webster round the same way, and so we'd have the same apportionment. And notice state D got below its lower quota, so that's a quota violation. I can have it go the other way as well. It's a little bit harder for Huntington Hill to go above its quota, but I have that here in this third example, because these two states are almost the same. So this does round down with Huntington Hill. I had to really fine tune it and look at those geometric means. But if I list them here, you can see the geometric mean of 2 and 3. Oops, right there's 2.4495, and so both of these are below 2.4495, so they would round down. And of course, the geometric mean of 4 and 5 is 4.4721, so this rounds down as well, and this one would round up. Of course, it's above 0.5, so it'll definitely round up. And so with this divisor, in that rounding, state D got above its upper quota. It got not just 23, but 24. So quota violations can occur with any divisor method, but it's generally pretty extreme cases, except for if you use Jefferson or Adams method. It doesn't have to be quite as extreme. All right, so one more divisor visit video to go. I just do everything in general, and then we'll look at priority methods as well. So hopefully we can see another method, and that's the way the census actually describes how to do Huntington Hill. They do it through what's called a priority method. So signing off.